Welcome back. Section 8, Set Operations, Set Identities, Computer Representations of Sets. Introduction. Two or more sets can be combined in many different ways. Let A and B be sets. The union of the sets A and B, denoted by A, U, B, is the set that contains those elements that are either in A or in B or in both. In other words, A union B is the set of all those x's such that x is an element of A or x is an element of B. So let's construct an example of union. So let's start with the set A to be, say, 1, 2, 3, 4, 5. Suppose set B is 2, 3, 5, 7, 8, 9. So what is A union B? Okay, you want to take in elements which are in A or which are in B. So notice you need to take 1 because 1 is in A. You need to take 2, 2 is in A. Notice 2 is in B also, but that's okay. As long as it is in one of the sets, you take in. 4, 5. So you took all the elements from A and then you see whether there is anything in B you missed out. 2, 3, 5, 7, 8, 9. That is the union. So union, you take elements from A or from B. Or means you take more. Okay. Now, let A and B be two sets. The intersection of the sets A and B, denoted by A upside down B, is a set containing those elements in A and in B. That is, A intersection B is the set of those x's such that x is an element of A and x is an element of B. In other words, look at A intersection B. Okay, so remember A union B, you took all the elements. Make sure we don't repeat elements because in a set elements are not repeated. Intersection, you are looking for those elements which are both in A and B. Okay, so common elements. So 2 is common to both. 3 is common to both. 4 is not common to both. 5 is common to both. And that's about it. So this is the intersection. That's the union. Okay. Here are Venn diagrams depicting union and intersection. So what did we do for union? You took everything from here and from here. Okay, combine them all. So you shaded everything in A or in B or common. Whereas intersection, you only took things which were common. So common to A and B, that's the region that's common to both A and B. Two sets are called disjoint if their intersection is empty. Okay, disjoint if their intersection is empty. So let's see. Suppose I take another set C. C consists of 10, 11, 12. Notice there is nothing common between A and C. Okay, A is 1, 2, 3, 4, 5. C is 10, 11, 12. So there's nothing common between A and C. There is nothing common between B and C as well. Okay, so A and C are disjoint sets. Likewise, B and C are disjoint sets. Okay. Prove the following formula for the cardinality of the union of two sets. Okay. Let So what is the formula for the cardinality of the union of two sets? This makes sure. So suppose A and B are both finite sets. All right. So what do we do now? A and B may or may not be disjoint, right? What if there is something in common, right? So let's say find the intersection of A and B. Suppose the intersection of A and B is A1, A2, dot, 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 A sub n. Okay, so there are n elements common in A and B. Well, what is A? Well, A has these common elements and possibly something else. So, all right, B likewise has the common elements and possibly something more. We don't know how many more. A has M more, B has T more than the commonality. So now let's look at A union B. Well, what is it? Well, you have something common, you don't repeat. All right, take everything in A and see whether you have missed out anything. Well, we missed out the y's which are only in B. Okay, so what does this tell us? Cardinality of A union B is what? N plus M plus T. Okay, what is cardinality of A? N plus M. What is cardinality of B? N plus T. All right, so notice if I add A and B, cardinalities of A, then what do I get? N plus M plus N plus T. So you see that gets me 2N plus M plus T. That is the intersection part gets repeated because one's from A, one's from B. So cardinality of A plus cardinality of B, if I subtract one intersection count, then I get, because A intersection B has n elements, I get rid of one of the n's and I'm left with n plus m plus t, which is cardinality of A union B. That's the result. Okay, so this is the case if A and B are finite. Okay, if even one of them is infinite, then the union is infinite. Okay, and the right hand side um, we don't address it not like this, because cardinality subtraction infinity minus infinity is meaningless, so we do not address this. Okay, so when even one of them is infinite, If both are infinite, then we are in big trouble depending on the intersection. But otherwise, this cardinality formula is spoken for finite sets. Okay. Let's continue. The difference of A and B denoted by A minus B, written like this, set minus, or written with a horizontal minus. Both are acceptable notations. A set minus B or A minus B is the set containing those elements that are in A but not in B. The difference of A and B is also called complement of B with respect to A. What is A minus B or set minus A set minus B? It's the set of all those x's such that x is in A and x is not in B. So for instance, here is A and B. What is A set minus B, right? From A, take away things from which are also in B. So 1 is okay, but you have to take away 2, 3 and 5. Likewise, what is B minus A? From B, take away things which are also in A. So 2, 3, 5 is not okay, but 7, 8, 9 is okay. So that is the difference. Okay. It's called the complement. Complement means outside of. So A minus B are all those things from A which are outside of B. Okay. Show that A minus B is not equal to B minus A. So here we have an example. We'll continue in our next video.